So we're going to start out with a Chapter 4 review. These first 3 questions were in Chapter 4, and we already took a test on it. These first 3 questions says find all the solutions between 0 to 2 pi of cosine x equals negative radical 3 over 2. So remember, to get x by itself, you have to do inverse cosine or arc cosine of both sides. Remember doing inverse cosine or arc cosine? I wrote arc, but it's the same thing as inverse. You guys remember doing that? Yeah. You don't remember doing that? That's the only way you can get x by itself. Or I could have done cosine to the negative 1. That means the same thing. I just thought I'd throw out arc because that's what those calc kids do. I ran out of lead. Fix that problem real fast. Okay, so what does arc cosine or inverse cosine mean? What does that mean? Where is the variable in this original question? In what place? The angle. It says what angle is cosine equal to negative radical 3 over 2. That's what we're finding, the angles. So remember, we want to think about where is cosine negative. In the second and third quadrant, cosine is x. That's where x is negative. And then where is cosine radical 3 over 2? So that's the memorization stuff. 30 degrees, 5 or 6? Okay, so that's my reference angle, but in the second quadrant, what is that? 5 over 6. And then we also have an answer in the third quadrant. If you want this to go fast, the pi over 6s in each quadrant that could possibly be an answer are the pi over 6s that don't reduce. So it's never 2 pi over 6. It's never 3 pi over 6. It's never 6 pi over 6. It's the ones that don't reduce. 5 pi over 6, 7 pi over 6, 11 pi over 6. The ones that don't reduce. Okay, so that's what our 2 answers would be. Again, this is review from Chapter 4. How about this middle one? Cosecant x equals radical 2. So you're doing inverse cosecant. You're doing you're finding the angle where cosecant is radical 2. So where is it positive? Because cosecant same as sine. And then what angle is it going to be a radical 2? Pi over 4 reference angle. So we have 2 answers. We've got a pi over 4. And then what pi over 4 is in the second quadrant, it does not reduce. And then the third one, we've got cotangent. The one that I have memorized is tangent of 30 degrees is the one with all the 3's. So if I'm asking cotangent of what is the one with all the 30's, it's not going to be 30. Yeah. And then this is negative, so we have to know that cotangent is negative in the second and fourth. It's going to be a 60, which is pi over 3 reference angle. But I need the pi over 3 that does not reduce in the second quadrant. And then the one in the fourth quadrant that does not reduce. So if you have these memorized, it's definitely going to take you a lot less time instead of drawing those triangles every single time. Now I encourage you to get on that if you don't have those memorized still.
Why did you write the whole arc thing in the beginning?
Oh, because when we have, I was just trying to bring up stuff we've done in the past, but if I gave you something like sine x equals 0.2498, then we would have to do arc sine or sine inverse. Remember arc and the sine inverse, same thing. You have to do that to both sides. Because that cancels out sine. That's how we get x by itself. And then how would I get this answer? You'd have to use your calculator. We are doing this. We're just not using our calculator. We just have it in our head. That's what we're doing to solve the equation. We're starting to solve equations that are more complicated. You guys have to know how to solve an equation. It doesn't just all of a sudden give you an answer. You're literally inversing both sides, but we don't always write it. Okay. Now it says find all the solutions. Up here I said find all the solutions between 0 to 2 pi. Now it should find all of them. So we're taking our solutions to cosine x equals radical 3 over 2, where the first one is at 5 pi over 6. But if I go all the way around the second time, I get another one that has that exact same answer. And if I go around another time, it's coterminal. It's going to have the same answer every single time. And remember, sine or cosine, they're periodic, and they go around and around and around. That's why the graphs look like that curve that goes on forever. So can you tell me how much I added to get to the next time it was 5 pi over 6? And then the next time? And then the next time? Or what if I went the other way? So we minus 2 pi. So what we're going to do is we're going to take our answer of 5 pi over 6, and we're going to add, how many 2 pi's am I going to add? K. 2 pi k or 2k pi, where k is an integer. How did you know that? We have done that. We did it when we were doing asymptotes. We were doing the same thing as we need to find all the solutions. But that's not all the solutions. That's only half of them. Because 7 pi over 6 is down here, and if I add 2 pi on the 5 pi over 6, it never gives me 7 pi over 6. So what I'm going to do is I'm just have a second answer. And how do I get all my other coterminals with 7 pi over 6? Same thing. Oops, I didn't mean to put a comma. Plus 2k pi, or 2 pi k, however you want to write it. Where k is an integer, same thing. So can you write all the solutions for the second one? Don't do the third one. Can you write all the solutions for the second one? Don't do the third one, it's different. Can you write all the ones for the second one? The one right above it, the cosecant, that one. Can you write all the solutions for that? How did you do? 5 over 4 plus 2k pi and 3 pi over 4 plus 2k pi? Where k is an integer. All right, now I just said don't do this one because this one was different. Let's see why this one is different. If I have pi over 3 as my first answer, and I only add pi, I will end up at the second answer. If I add pi, I will end up at that second answer. So if I add a pi again from the second answer, I will end up at the next one. Well, I'm going to start on my first answer, 2 pi over 3. And I'm going to add k pi, where k is an integer. But I don't even have to mention 5 pi over 3 because when I add on pi from 2 pi over 3, it ends up at 5 pi over 3. And that's because the period for tangent is pi. It like repeats every pi. Where the other two, the period is 2 pi. So that's why what we're adding is different. So you don't even have to mention the second one for tangent. Okay? All right, the rest of these, we're only finding the answers between 0 and 2 pi. But if you were asked to find all the solutions, which there's like 2 questions in your assignment that do that, there's examples there. All right, the last one, we are just solving equations, and then you're going to solve them so you get like sine x by itself. And then once you once you get it so sine x is by itself, then it's just like solving these that we've already done in chapter 4. So how am I going to get sine x isolated? How am I going to get sine x by itself? Subtract 1, divide by 2. So then sine negative half, so sine is negative in the bottom 2 quadrants. What reference angle is a half? 30 degrees, so pi over 6. And then what is the pi over 6 in the 3rd quadrant? And then in the 4th quadrant? Good. So the next example, we're going to add 3 and divide by 4. But we do not know where cosine squared x equals 3/4. We only know where cosine x equals something. So how do I change cosine squared into just cosine? You square root both sides. But if I square root both sides, what else do I have to do? No, not yet. But something else. When I square root, I'll put something there. Come on. Plus or minus. Yeah. I knew you knew it. I knew it. I knew it. So when we put that plus minus in there, we're going to have cosine x equals plus minus. I'm going to do the square root of 3. I'm also going to do the square root of 4. So when you do a square root of a fraction, you just do the numerator and denominator separate. So do I have to rationalize? No, because the square root of 4 is 2, and I don't have to rationalize. And that looks familiar now. The only part that is new at this point is the plus or minus. So what I'm going to do is I'm going to say, where is cosine positive or negative? All 4 quadrants. Guess how many answers I'm going to have? 4. So what's the reference angle for cosine being radical 3 over 2? Pi over 6. So we've got pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. We've got all 4 answers. When you're ready to go on, you flip your page over. So our next one, I look at this one, and I say, that kind of looks like what we were doing last night. It looks like something was factored. You see the parenthesis? It looks like a distributive question. But I don't want to distribute it in. I'm actually going to leave it factored. I'm not going to distribute it. I want to leave it factored because it equals 0. And it's factored. I'm going to set each factor equal to 0, and I can solve for each separate factor. So these are like having 2 math problems in one. Kind of like what you had last night with your factoring assignment. After you factored it, and you solved 2 separate x's. And you just put them together as your answer. So we're going to do the same thing. So now, secant x equals 1. I don't have my secants memorized, so I'm going to change this to cosine. If you have your secants memorized, that's totally fine. But what would cosine equal? Undefined. Excellent. And then you think of that cosine graph that looks like this. And if it's undefined, it will be an asymptote. Where does cosine have an asymptote? A vertical asymptote. Where does cosine have a vertical asymptote? Cosine never has a asymptote. So what happens is sometimes parts of this information don't give you an answer. They don't give us an answer. I'm just going to reject that. Keep it. Graphically, I can show you that, but I don't know if I'll have time today, but we'll definitely have time on flat day. Okay? So now I'm going to go rid of this one and just solve this one. So now I need to know where secant x equals 1, and I don't know my secrets, so I'll change it into cosine. And I want to know where cosine is equal to 1. 0. Is it also at pi? Yeah, but 2 pi is not going to be an answer. We're going to stop before 2 pi, so just 0. At pi, it equals -1, right? So there could be pieces of information in here that don't give you an answer. Okay, how about this next one? Can you guys start this next one, please? Because I think we already did one like this on the front. So I want to see if you're understanding the material. We'll walk around while you're working on this one.
Also, do you
Oh, yeah. So you have more answers. All right, I've walked around. You guys are definitely on the right track. Let's see. Added 4 divided by 3. Square rooted. Okay, then some of us rationalized here. Totally fine. Some of us just flipped it at this point and said sine. So they could avoid rationalizing. If you rationalized it, it would be 2 radical 3 over 3. And if you have that memorized, that's great, but a lot of us only have like sine memorized. So flipping it, I just need to know where sine is, positive or minus radical 3 over 2. So that's all 4 quadrants. I know it's not 30 degrees. It's 60, but that's going to be pi over 3. And then it's all the pi over 3s that don't reduce. All right, one last question. So we look at this and we say, there's a bunch of parentheses and it equals 0. What do you think maybe has already occurred? It has been factored. Gosh, I wonder what we're going to do in the next lesson. Okay, but this one has already been factored. So if it's already been factored, what are we going to do with each factor? I'm going to set each factor equal to 0. And solve each factor. So I added, I divided, I square rooted. When I square root, I have to have a positive minus. I have to have plus minus. And I got that cotangent x is plus minus radical 3 over 3, or cotangent x is plus minus radical 3. I do need to know which is which. What's the answer for cotangent for the radical 3 over 3? About 30 or 60? 60. Yeah. So pi over 3 is over here. And then on this one, it's going to be the pi over 6's, but it is every quadrant. So I'm going to kind of like put them both on the same picture. I could even color code them so you can see. I'm trying to make them like these are going to be the pi over 6's because they're smaller. And then my pi over 3's would be more like that. And I'm doing this because how do we write our answers? Least to greatest. So I'm going to think least to greatest. I'm thinking about going around the circle. The first thing that I come to is pi over 6. Then my next one is pi over 3. What is the third answer I come to? 2 pi over 3. Then 5 pi over 6. So there's the top half. After I get to pi, what's my next one I go to? 7 pi over 6. Then 4 pi over 3. 5 pi over 3. And then finally 11 pi over 6. So that is the correct order for all 8 answers. So the worksheet number 1 coming out to you is the only thing that is being graded tomorrow. The only thing that is being graded tomorrow. Should you start working on your review for your quiz on Friday? Should you get on Canvas once I have it posted and check your answers to the review that we didn't check today? Yes, however, you might have a right answer, and it doesn't look like mine, but it doesn't matter. Really important that you start asking questions tomorrow to get your stuff on for that quiz. Just wondering if she has like modeling.